Hi everyone, Ravi this side. Welcome to Engineering Radar. In the previous video, we have discussed about the encryption and decryption in brief and their types like symmetric encryption and asymmetric encryption. Everything we have discussed in brief in that particular video. So that was the introduction video, and here in this video, we are going to see what is symmetric encryption and how we can achieve the symmetric encryption through AES algorithm, and how we can practically try to encrypt some messages and decrypt that particular encrypted message in our Spring Boot application through some APIs. Everything we are going to discuss in this video. So let's get started for that, and let me try to go to the next slide and brief you about the symmetric encryption first, its advantage and its disadvantage, and then after that we'll try to implement it practically through creating a Spring Boot application. So if you are new to the channel, please like the channel and please subscribe the channel. And if you are new to this topic of encryption and decryption, I will recommend to watch that particular video. I will provide the link of that video in the description of this video so that you can start from there, okay, and get the basic idea of encryption and decryption in Spring Boot. Now let me try to go to the next slide and discuss about the symmetric encryption. So symmetric encryption, also known as secret key encryption, employ the same key for both encryption and decryption processes. So we already have discussed that in the symmetric encryption, we have one key which is shared among the encryptor and decryptor. Okay, the same key is being used for encryption as well as decryption. The key is typically a sequence of binary digits, which is called as bits or characters. Symmetric encryption algorithm includes DES, Data Encryption Standard, AES, Advanced Encryption Standard, and Triple DES. So here in this video, we are going to use the AES algorithm to do encryption and decryption for the symmetric encryption. Now let me try to go to the next slide, and this is the picture. Okay, I think I have used the wrong picture here. This is for the asymmetric because we are using the public and private key. But let me try to show you how the encryption is being done with the symmetric key. So let me try to go back, and here you can see that symmetric encryption, how it is being achieved. So we have the plain text. With the particular secret key, we are going to encrypt that plain text into the ciphertext, and then with the same particular secret key, we are going to decrypt out and get the plain text back. So this is what symmetric key is. But in the case of asymmetric key, we have two different keys, or you can say we have the pair of keys, one for encryption, another for decryption. Okay, so this is about the symmetric key. With the same key, we are going to encrypt and decrypt the messages. Now let me try to go there and give you the advantage and disadvantage of the symmetric encryption. So here the advantages involves like speed, scalability, and less computational overhead. So coming to the speed, symmetric encryption algorithms are generally faster and more efficient than asymmetric encryption algorithm because they involve simpler mathematical operations. Okay, so asymmetric encryption algorithms are generally faster. Okay, than the symmetric encryption are generally faster than the asymmetric encryption. Coming to the scalability, symmetric encryption is more scalable for encrypting and decrypting large volume of data. So it is also scalable. Now coming to the third point, which is less computational overhead. Due to their simplicity, symmetric encryption algorithm incurs less computational overhead because the same key is being used for encryption and decryption. So there is a less computational overhead in symmetric encryption, so making them suitable for resource constrained environments. So this is the advantage of symmetric encryption. It is more speedy, scalable, and it has less computational overhead. Coming to its disadvantage, we have the first disadvantage is the key distribution. So you already know that in the symmetric encryption, we have the same key for encryption and decryption. So there is a major challenge in symmetric encryption is securely distributing the secret key to both sender and the recipient. So distribution of the secret key to encryptor and decryptor is a major challenge here in the symmetric encryption. If the attacker intercepts the key during the transmission, they can decrypt all the encrypted messages. Okay, so the first disadvantage is key distribution. Now the second one is key management. As the number of communication parties increases, managing and securing storing multiple keys become increasingly complex. So let's say we have only two parties as of now. So in that case, it is it is easier to manage the keys. But if the number of parties increases, managing of the key is becoming very much difficult, or you can say less secure. Okay, so key distribution is a major challenge. Key management is a major challenge. Coming to the third challenge of symmetric encryption is limited trust model. Symmetric encryption requires a high level of trust between the communicating parties, since both parties possesses the same secret key. So these are the three disadvantages you can say for the symmetric encryption. Now let me try to come out of it and go to the IntelliJ and try to create a application there. Okay, so let me try to create here. So we are in IntelliJ and I'm using IntelliJ Ultimate version so that we can directly come here and create a Spring Boot application. If you are not using the IntelliJ Ultimate version, what you can do is you can go to the Spring IO and there you can create your Spring Boot application. So let me try to go to the new file and project, and here you can directly go to the Spring Boot and create your Spring Boot application. So let's say here I'm going to create the Spring Boot application. Say it is symmetric encryption and let's say decryption. Okay, select the Maven here and go next. Okay, so something is wrong. Okay, symmetric, let's say, and this symmetric, go next. And here let's say it is we need to use this string web. Select that particular artifact, or you can say dependency, create this and then open it in a new tab. Now it will take few seconds of your time to try to download all the necessary dependency that we have added and configure your application. So just wait for a few seconds before starting the real development. Okay, so just wait here. Now, okay, I think we are good for the development. Just go to the source main Java, and here let's say we are going to create. So first of all, what we are going to do is we are going to create a service layer and a controller layer. Okay, so in the service layer we are going to create two methods. One is for the encryption and the second one is for decryption. And in the controller layer we are going to create two APIs. One is for encryption and the second one is for the decryption. So that is what we are going to do here. Okay, so let me try to create the encryption service and just let me try to annotate this with that there is service annotation. Now what we need to do is we need to create the two methods. One is for encryption and the second one is for decryption. Okay, and here when we are going to create those encryption and decryption methods to encrypt and decrypt the messages, we need the key as well. So how we can generate AES key, or you can say the key to encrypt and decrypt the messages, that we are going to see first. So let me try to show you how you can generate the key that you can use for encryption and decryption. So let me try to go to this application first, and here let's say it is main method, and here let me try to write the code to create the keys. Okay, so let's say we are going to use key generator, and key generator get instance for AES. So we are going to use this advanced encryption standard algorithm, and we are good. I think it is giving some error. We need to put it in the try and catch. So just surround by try and catch, and we are good. Now once the key generator is there, what we need to do is we are going to use this secure random to create a random secure random object, because we are going to use this to initialize the key generator. Okay, so sorry. Let me try to put here new, and then key generators dot init, and here we have to provide this key size and the secure random object. Okay, so let's say secure random object we are passing here. Apart from that, we need to provide the key size. So let's say I'm going to use the key size as 128. Okay, and okay, it is not like we can pass it as an integer here, so we are good. Now what we need to do is we need to create the secret key using this key generator. Okay, so just create the object of secret key, and then key generator dot generate key, and it will give you the key. Now what we need to do is we need to encode this key into the string format. Okay, so just create an object. Let's say it is a base 64 key, and we are going to encode it in the base 64. So just base 64 dot get encoder, and then encode to string, and here we need to pass that secret key. Okay, and okay, so it is secret key dot get encoded, and we are good. Now this is the key that we can use for encryption and decryption. Okay, so let me try to print out this base 64 key that we are going to use. So just we are good. Now let me try to run this and generate our key here. Okay, so we have the key. Just copy this particular key, keep it somewhere safe. Either you can open a notepad here and try to keep it there. So just paste it here. So this is the key that we are going to use. Now I'm just going to remove this print statement from here. So this code is needed only one time, so that you can generate your key that you are going to use later on when you are going to encrypt and decrypt your messages. Okay, so you can remove this piece of code. This is only to show how you can create your key that you are going to use for encryption and decryption. Okay, now coming back to the encryption service. Now let me try to create the method here to encrypt and decrypt out. Okay, so just let's say public string encryption or encrypt, something like that, encrypt, and we are going to encrypt let's say string data. So here we are just taking a simple example of string data. Okay, now first of all what you need to do is you need to generate the key. Okay, so just key equal to new. Let's say we are going to create a method called generate key, and we are going to use that. So just import this key and write down this method. So this method is going to generate the key for you. So just let's say private, it is returning the key, and okay, so let's say it is returning new secret key spec. And here you have to pass the secret key that you have generated and the algorithm that you are going to use. Okay, so the secret that we have generated, I have kept here in the notepad, right? Let me try to copy this piece of code. And here let me try to create a variable here. So let's say it is public the static final string. Let's say it is something like secret key. Put it there. And I also just want to pass the algorithm as a string here. So just create a second thing. Let's say AES. Okay. Now we are good. Here we need to pass this both things like secret key that we have generated and the algorithm that we are going to use. So it is AES. Okay, and we are good. Okay, so it is secret key.get bytes. Okay, I think we are good. So here what we are doing is okay, why it is okay. Now we need to call this generate key here. So let me try to do that. It is not new. It would be generate key, and we are good. We have the key. Now what we need to do is we need to create the object of cipher and initialize it with the algorithm that we are going to use. So just create the object of cipher. I'll get instance, and then we have to pass the AES here, the algorithm that we are going to use for encryption and decryption. Okay. So why we are getting this error? Okay. We are good. Now initialize this cipher with the mode and the key. Okay, so just let's say it is cipher. Cipher.init, and we have to pass the mode here. So you can pass the mode as either encrypt mode or decrypt mode. So here we are going to encrypt out. So we are passing the mode as encrypt, and then we have to pass the key that we have generated above. So it is key that we need to pass here, and we are good. Okay, so what it is giving? Okay, invalid key exception. So what we can do is we can try to keep them in the try and catch. What you can do is you can directly throw the exception here. If you don't want to keep all these exceptions being thrown here, you can directly throw the parent, which is exception. Okay. Now let me try to try to generate the encrypted value here. So let's say it is byte. Let's say it is encrypted value. Okay, now we have cipher.doFinal, and here we have to pass the data that we are going to encrypt out. So just it need to be there in the get bytes format, and what it is. Sorry, let me try to check. Again, some exception we need to throw. And then once we have the encrypted value, what we need to do is we need to encode it to the string and try to return it out. So just return base64 dot get encoder dot encode to string, and then we need to pass the encrypted value, and that's it. So this is how we can encrypt out our messages. Okay, or plain text, you can say. Now we need to write the method for decryption. Okay, so let me try to copy this piece of code that we have written for encryption, paste it here, and then change something here in the decryption. Okay, so decrypt. We are going to decrypt the encrypted value. So let's say it is not data, it is encrypted value. Okay. Right. Encrypted data, something like that. You can pick. Again, coming to the decryption, you have to generate the key, which is we are doing here, and then you have to create the cipher object, which we are doing again in the next line, and then you have to initialize that with the decrypt mode. Okay, so just change this mode to the decrypt mode. You have to pass the key as well. Now, what we have to do is we have to generate the decrypted value. So just remove this. Let's say it is decrypted value, and then we have to call the do final, and then we have to decode it. So just base 64. Let me try to pass these strings here. So base 64, and then we have to pass dot get mime decoder, and then decode. In the decode method, we have to pass the encrypted data. Okay, and then what we have to do is we have to return a string of decrypted value. So just remove this piece of code. Return string, something like new string, right, of decrypted value, and we are good. So we have created the method for encryption and decryption here. First of all, what we did is we try to generate the key, and then we have created a method for generating the key by passing the key that we have generated from the previous code. You can see this, right? And then we are also passing the algorithm that we are going to use. Once the key generate key method is completed, we have created these two methods, one for the encryption, another for the decryption. So in the encrypt method, we are generating the key. We are creating the cipher object, initializing it with the algorithm that we are going to use for encryption and decryption. And then we are trying to encrypt and decrypt the data. Now let me try to create the controller here. So let's say it is sample, or you can say encrypt decrypt controller. Okay, just annotate this with @rest controller, and let's say here we are going to create this two APIs. One is for encrypt, another is for the decrypt. So let's say encrypt, and let's say it is public string, something like encrypt. And we have to pass this the data that we are going to encrypt as a request body. So let's say here we are passing this data as a request body, and then we are calling this method of the encryption service, which is encrypt. So how we can call it out is we need to auto wire that service here. So let's say auto wire private encryption service, and we are directly going to use this object to call the method. So let's say encrypt method, we are passing the data here, and we have to throw all the exceptions here. Okay, and then simply return it out. We are good. The same thing we have to do for the decrypt as well. So here we are going to create the decrypt API. Okay, now let me try to change this to decrypt. We are passing the encrypted message as a request body. So let's say it is encrypted data, encrypted. Okay, and the same we have to pass when you are going to call the decrypt method. Okay, so this is the whole flow. So let me try to show one of the API here. So let's say we are going to use the encrypt API. So we are going to hit this API. We are passing our data that we are going to encrypt, and then when we are going to call the encrypt method of the service layer, we are passing the data that we need to encrypt, and then inside this encrypt method we are going to generate the key, initialize the cipher, and then encrypt out our data and then return it. Similarly, when we are going to decrypt out, we are going to have a encrypted value, and then we are going to generate the key, initialize the cipher, and then decrypt out that encrypted value and then return. So this is the flow. Let me try to run this application and try to hit the APIs. So just run this application and go to the Postman, and here what we have is our application will be up on the port number 8080 because this is the default port. And let's say we are going to call this encrypt API first. Okay, so our application is up. Let me show you. Our application is up on the port number 8080, and if you go to the controller, and if you're going to hit this encrypt API, you have to pass the data that you want to encrypt and then hit this API. So we are going to hit this API, and the data that we are passing is as a hello world or anything you can pass. So let's say I'm going to pass the engineering or something like that. Okay, and then hit this. Now here you can see in the response we are getting this encrypted value. So just copy that and go to the other API for decryption. So I'm just have created two requests here. So here I'm pasting that encrypted value, and here I'm going to call the decrypt API. So just try to hit it, and you're getting the response as engineering data. So that means your encryption and decryption APIs are working fine. You're able to encrypt the message that you want to encrypt, and then you're also able to decrypt the message that you want to decrypt by hitting the encrypt and decrypt APIs. So this is about the symmetric encryption and decryption in Spring Boot application. If you like the video, please hit the like button and please subscribe the channel for more such content. Don't worry, I will provide the link of the GitHub for this application, like what I'm going to post this application on my GitHub account, and then I will provide the link of that GitHub application in the description of this video, so that you can directly go there and try to, if you want to clone this application, you can clone it out and practice at your end, or if you want to specially develop it out, you can also develop there. So this is about the video, guys. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.